subgroups டாபிக்லேருந்து சில பேசிக் டெஃபினேஷன் தியரம்ஸ் பார்க்குறோம். Subgroups: a non-empty subset H of a group G is said to be a subgroup of G if under the product in G, the binary operation in G, H itself forms a group. Next, if H is a subgroup of G and K is a subgroup of H, then K is a subgroup of G. A non-empty subset H of a group G is a subgroup of G if and only if A, B belongs to H implies AB belongs to H. A belongs to H implies A inverse belongs to H. If H is a non-empty finite subset of a group G and H is closed under multiplication, and then H is a subgroup of G. Let G be a group, H a subgroup of G. For A, B belongs to G, we say A is congruent to B mod H, written as A congruent to B mod H if A, B inverse belongs to H. The relation A congruent to B mod H is an equivalence relation. If H is a subgroup of G, A belongs to G, then HA is equal to the set of all HA such that H belongs to the capital H. HA is called a right coset of H in G. For all A belongs to G, HA is equal to the set of all X belongs to G such that A congruent to X mod H. Any two right cosets of H in G either are identical or have no elements in common. There is a one-to-one correspondence between any two right cosets of H in G. If G is a finite group and H is a subgroup of G, then order of H is a divisor of order of G. If H is a subgroup of G, the index of H in G is the number of distinct right cosets of H in G. Note, the index of H in G is denoted by Ig of H. In case G is finite group, Ig of H is equal to order of G divided by order of H. If G is a group and the element A belongs to G, the order of A is the least positive integer n such that A power m is equal to E. If G is a finite group and A belongs to G, then order of A divides order of G. If G is a finite group and A belongs to G, then A power order of G is equal to E. Next, Euler's theorem: if n is a positive integer and A is relatively prime to n, then A power pi of n is equal to 1 mod n. Note, pi of 1 is equal to 1. For n greater than 1, pi of n is equal to the number of positive integers less than n and relatively prime to n. Pi of n is a Euler function. Pi of 8 is equal to 4. 1, 3, 5, 7 are relatively prime to 8 for numbers. If n is a prime number, p, phi of p is equal to p minus 1. Fermat's theorem. If p is a prime number and a is any integer, then a power p is congruent to a mod b. If G is a finite group whose order is a prime number p, then G is cyclic group. The center Z of a group G is defined by Z is equal to set of all Z belongs to G such that Zx is equal to Xz for all X belongs to G. It's called a center of the group. The center is a subgroup of G.